Hi, Assalamualaikum. My name is Muhammad Hafiz bin Rahim. I'm from BMMP Section 2. My supervisor name is TS Dr. HANIZAM bin HASHIM. The topic for this research is design and develop device to transform dendritic to the spherical microstructure of aluminum alloy for semi-solid processing. So, the problem statement that I find for this research is in recent year, the collision slope is one of the method that used for get dendritic shape or globular shape. By this type of technology, it cannot implement this type to all application. The reason is gas interaction, contamination of slurry by the chemical reaction and oxidation, difficulty of controlling the process. After we found the problem statement, so the objective of this research is to create a design that we call spiral channel to change the dendritic microstructure into non-dendritic microstructure. Secondly, to fabricate and produce a spiral channel that is for the casting process. And lastly, to analyze and compare the grain microstructure using spiral channel with another method. Scope of research consists focus on design of the spiral channel. Next, the material that we use for this research is aluminum alloy with grade A356. And lastly, the temperature and angle needed or desired during the curing process. Okay, this slide is my Gantt chart for my project planning. As you can see here, the green tick it refer to my planning, and the yellow one is refer to my actual process. Okay, next I will cover the next slide with the literature review of this research. Permanent mold casting is one of the type that we use for this research. Basically, this permanent mold casting widely used for complex shape, usually made from metal, consisting of two or more parts. It can repeatedly used for the production. In permanent mold casting, molten metal flow into the mold by gravity. Non-ferrous metal and typically used in this process such as aluminum alloy, magnesium alloy, and copper alloy. This type of casting produce automotive parts such as wheel, bracket, piston, pump impeller, and many others. Okay, what is SSMP? SSMP is a short standard for semi-solid metal process. So this SSMP can determine as discovered by and developed at MIT. It also casting and forming operation are used in this manufacturing technique.
regarded as economical, high productivity process for manufacturing a broad variety of metal parts. As we know, this SSMP is a new technology for metal forming, different from the conventional metal forming technology, which use solid metal or liquid as a starting. So year by year, this semi-solid metal processing technology improve their mechanical properties and complex shape. Semi-solid state metal processing is a near net to shape. It means it meet to the non-retic microstructure. The process is used with non-ferrous metal such as aluminium, copper, and magnesium. Now, I will explain about dendritic form. This dendritic form is look like a tree shape, or we call a crystal shape. So how this dendritic can form or grow? So when alloy solidified, the most common structure seen in dendritic structure, and this dendritic structure has a most complex pattern that develop from dynamical growth process. It's hard to understand this pattern, and it's important to us to know the pattern form. And lastly, we need to know and understanding the different dimension of this structure. As you can see here, this is the several technologies used to change the dendritic to non-retic microstructure. So I list five here. First, we have mechanical steering, magnet hydrodynamic steering, cooling slope, new MIT, and liquidus casting. On mechanical steering is developed at MIT. Steering of liquid alloy while control cooling in the semi-solid range using agar, impeller, and pedal. Batch type of continuous process. This for reo casting and theo casting process. By magnetic hydrodynamic steering method, this method patented by Alumax, and magneto-hydrodynamic steering mostly widely used process. Vigorous steering by rotating magnetic field within the mold, normally for producing feedstock for tissue casting. This integrate fine dendritic which convert to globular grain or partial melting. As you can see in this figure, this is cooling slope method. This cooling slope method is simple non-agitation process. This method also applying a low superheat. For controlling parameter, for example, is the length of the slope or the angle of the slope. For the fourth point is a new MIT, known as a semi-solid reo casting, or we call SSR, holding molten metal slightly above its liquidus temperature to reach a homogeneous temperature. Insert cool rod into melt to stir. Withdraw the stirrer and insert the metal directly into casting device. Lastly, of the mechanism of non-retic is liquidus casting. liquidous casting is the pouring of the melt at near liquidous temperature. This method higher rate of nucleation favoring fine grain size. It also on partial melting fine grain transform to globular grain. It also known as a new Rio casting. Okay, now let's continue about my methodology for this project. Now I will explain about process flow of this project. First, I generate the concept for this project. So I name it as a spiral channel concept. After we get the concept, I develop two design or two drawing using CATIA V5 software. After I do the design, I make sure to select which drawing is better or have a great benefit to fabricate. To fabricate this spiral channel, I use my steel to fabricate this spiral channel. And the process for fabricate this spiral channel, I use sheet metal process and welding process. After we assemble the product and part, we do a run test. After we collect the data, we need to compare this data to another method to see the microstructure of aluminum alloy. We observe or using optical microscopy to analyze this microstructure. Here is my design for the spiral channel. So design number 1, the length for the design number 1 is 250 mm and diameter is 80. For design 2, the length of spiral channel is 302 mm and the diameter for this spiral channel design 2 is same as the design number 1, which is 8 mm. Lastly, we go to the preliminary finding. Okay, in this slide, this is the selection design. So design number 2 was selected. This is because the length of this design is 202 mm and more longer than design number 1. The reason why I choosing that because we know the longer of spiral channel made, it can give advantage to the pouring process because we want to the structure of the dendritic to cut off and speedily before get into the mold. Comparison between dendritic and non-dendritic microstructure. As you can see, the dendritic microstructure is look like a tree shape, and for the non-dendritic is like a globular. What we can compare is as you can see, the dendritic microstructure have a porosity, so it give a low strength, and if we want to do a tensile stress or yield stress, maybe non-dendritic microstructure can get a good result compared to dendritic microstructure. Effect non-dendritic for semi-solid metal processing. It can change the mechanical properties such as hardness strength, yield strength. So number 2, reduce shrinkage during solidification. And lastly, we want to eliminate air entrapped during pouring process into the mold. In conclusion, we can conclude that the mechanism hardware to change the non-dendritic form, we have many key and many technique to implement to this. So that's all from me. Thank you.